This video will continue our discussion of limits with the idea of continuity. In the past, earlier in this course and in Calc 1, using continuity, we'd use limits to define that. Thankfully, when we're talking surfaces, a function is continuous at any point where it's defined. So if we can just find the domain, then we have found where it's continuous. So we just look at it looking for discontinuities. Okay, well, I see this x squared plus y squared plus 1 equaling, it can't equal 0. That's in the denominator. So if I work this out a little bit, this means x squared plus y squared cannot equal negative 1. Well, if I look at that's never going to happen, right? If I pick any x or any y, because I'm going to square it, it's going to make it positive, and then adding keeps it positive. So I'm going to write continuous. This is continuous everywhere. So we're going to say continuous on, and we make a set, x, y, such that we're going to just say xy is inside of, that's what that symbol means, is an element of R2. That's just any x and y will work. Every number works. All right, if we look at this next one, we have a couple trouble spots. We have x over y. That tells me that y can't equal 0. I also have the square root of x, which tells me that x has to be non-negative. It can be 0 or it can be positive. So this is continuous on all xy's such that, okay, and we just have to follow those rules. Y can't equal 0, or we should probably use and. It's not one or the other, it's both. And x is greater than or equal to 0. We have to satisfy both of those. If we can satisfy both of those, then it's continuous at that point. So it's just another domain question. All right, got a couple more here. Okay, here, okay, find the set of coordinate pairs where the function is continuous. Again, we're looking at domain. I see x squared plus y squared in the denominator. That means they can't equal 0. Well, think about that for a moment. What x's and y's would give me a 0 there? Well, the only thing that's going to work is the point 0, 0. That's the only thing that would make a 0. Any other numbers are going to make positives. They can't even cancel out. So this is continuous on everything except for that. Continuous on all xy's such that xy cannot equal 0, 0. All right, so as long, and that one's going to be this whole surface, but at the very origin, it's just discontinuous. It's not there. Okay, I got one more here. All right, this one, I got x squared plus y squared plus z squared minus 4. Can't equal 0 because it's in the denominator. Well, that's just x squared plus y squared plus z squared can't equal 4. Okay, well, hopefully you recognize what that is. That is a sphere. So this surface, or this isn't a surface, this is in 4 dimensions, right? So whatever this looks like, the only thing that's not going to graph, and remember in this case, our domain is a surface, and we're mapping a surface to 4 dimensions, whatever that looks like. So the only thing that's not going to work, the only surface, is this sphere that has a radius of 2. So this is continuous on everything except for that sphere. So that's all xy's and z's such that x squared plus y squared plus z squared can't equal 4. So that would cover every x, y, and z. That's not when you, in that relationship, when I square them and add them together, they're not equal to 4. So we're literally, in our domain, we're just missing a sphere of radius 2, centered at the origin.